Okay, for this guided practice, the given information is that x is the midpoint of sy and z is the midpoint of yf. And they also tell me that the length of xy is equal to the length of yz. So, in order to help me understand this problem a little bit better, I'm going to draw a picture. So, x is the midpoint of sy, means I have a line segment called sy. And they tell me that x is the midpoint, so I'm going to put x right in the middle. Then they tell me that z is the midpoint of another segment, yf. So I'm going to make another segment. Y is already a point that we have on our picture here, so when I make this line segment, I need to extend it on here. So this one is going to be line segment yf. And then the midpoint of that one is z. And they also tell me that the length of xy is equal to the length of yz. So let's put some information on here. They tell me that these two are equal. Because x is the midpoint of that first one, then I know that this segment is equal to this segment. And because z is the midpoint of yf, then I know that this segment, I'll use three ticks this time, is congruent to this segment. Now visually, I can see that since these two both have green marks on them from our given information, and one of them also has 2 ticks and the other one has 3 ticks, then that would mean that this first segment and this third segment would also have the same measure, which is exactly what they're asking me to prove here. So what I need to do is go through the logical sequence to get there. So let's see how we get there. All right, so starting with the given information, just listing everything. X is the midpoint of sy, z is the midpoint of yf, and the length of xy is equal to yz. The reason is given. Now from that, I can say that sx is congruent to xy, looking at my picture to help me understand what's going on here. Sx and xy are congruent, and the reason for that is because x is the midpoint. So this would be definition of midpoint. There's another piece of information here, though. YZ is congruent to ZF, YZ to ZF. So that is also definition of midpoint. So this is definition of midpoint for our reason. Okay, from that, I can get some more information now. Let's see. Actually, no, that's going back to my given information. Them telling me that XY, the length of XY is equal to the length of YZ. By definition of congruence, I can say that those two line segments are congruent to one another. All right, now that I have that information, I can come back here and look. This says SX is congruent to XY. My next statement was XY is congruent to YZ. So I can say, because YZ and XY are congruent, I can say that SX is also congruent to YZ. That would be by the transitive property. All right, next up, also by the transitive property of congruence. I clicked the wrong button. Now I can't see my tools. There we go. Okay, so also by the transitive property of congruence, I can say then that SX is congruent to ZF, since SX to XY, XY to YZ and then Sx to Yz also. That takes me Sx to Zf. My transitive property. And then the statement I'm trying to prove is that line segment ZF is congruent to line segment SX. And that's just this statement in the opposite order. So I can do that by symmetric property. Oops. Okay, this is the wrong thing. So this is supposed to be symmetric. I'll just write that in. And that is the proof.